Imagine a world where computers can solve problems in seconds, problems that would take today's supercomputers millions of years. Sounds like science fiction, right? Well, welcome to the era of quantum computing. In the race to solve the world's biggest challenges, traditional computers are reaching their limits. But there's a groundbreaking technology just around the corner, one that promises to change everything: quantum computing. From artificial intelligence to curing diseases, quantum computers hold the potential to revolutionize industries and unlock secrets of the universe we never thought possible. But what is quantum computing? How does it work? And why is it considered the next major leap in technology? Let's dive in. The concept of quantum computing dates back to the early 1980s, when physicist Richard Feynman proposed that classical computers might not efficiently simulate quantum systems. This idea laid the foundation for a new paradigm in computing. Over the decades, numerous scientists have contributed to the development of quantum theories and algorithms, leading to the emergence of quantum computing as a field of study. At its core, quantum computing is based on the principles of quantum mechanics, the branch of physics that explains how tiny particles like atoms and photons behave in ways that seem almost impossible to imagine. While classical computers use bits, which represent data as zeros or ones, quantum computers use qubits. Qubits are different because they can represent 0, 1, or both 0 and 1 simultaneously, thanks to a quantum phenomenon known as superposition. This gives quantum computers the ability to process a massive amount of data simultaneously, making them exponentially more powerful than traditional computers. Another key concept is entanglement, a unique quantum phenomenon where the state of one qubit is directly related to the state of another, no matter the distance between them. This means that quantum computers can perform complex calculations much faster and more efficiently than anything we've seen before. So why is all of this important? Because quantum computing could solve problems that are currently beyond our capabilities. Here are just a few areas where it could have a game-changing impact. Artificial intelligence. Quantum computing could take AI to a whole new level. Quantum algorithms could enable AI systems to solve problems like pattern recognition, decision-making, and optimization much faster than current technologies. Drug discovery and healthcare. With quantum computing's ability to simulate molecular structures with incredible accuracy, it could accelerate drug discovery, helping researchers find cures for diseases like cancer, Alzheimer's, and HIV far faster than traditional methods. Cryptography. Quantum computers have the potential to break current encryption methods, which could pose a serious security risk. However, they could also be used to develop new forms of encryption, making data safer than ever before. Climate change. Quantum computing could revolutionize climate modeling and simulation, enabling us to predict environmental changes with unprecedented accuracy and speed, helping fight climate change with better solutions. Financial modeling. Financial institutions are exploring quantum computing for risk analysis and optimization of investment portfolios. Logistics and supply chain management. Quantum algorithms can optimize complex logistical operations, improving efficiency in delivery routes and supply chain management. While the potential of quantum computing is enormous, we're not there yet. The technology is still in its infancy, and several challenges need to be overcome before it can live up to its promise: stability of qubits. Qubits are incredibly fragile and can easily be affected by even the smallest environmental factors like temperature, radiation, or electromagnetic fields. Researchers are working on making qubits more stable and less prone to errors. Scaling the technology right now, the number of qubits that can be used in quantum computers is limited. To make truly powerful quantum computers, we need to scale up the number of qubits, which requires building more advanced systems. Quantum decoherence. Maintaining the coherence of quantum systems over extended periods is challenging, which affects the reliability of quantum computations. Quantum software and algorithms. The software and algorithms needed to harness quantum computing are still being developed. Unlike traditional computing, quantum computing requires entirely new programming languages and frameworks, which scientists are still perfecting. Integration with classical systems. Developing hybrid systems that integrate quantum and classical computing resources poses both technical and architectural challenges. Many of the world's biggest tech companies are heavily investing in quantum computing. Here are some of the leading players in the field. Google made headlines in 2019 when they claimed to have achieved quantum supremacy, a milestone where a quantum computer solved a problem that would be impossible for a classical computer. Google is still one of the leaders in the quantum race, with plans to build a large-scale quantum computer within the next decade. IBM has been a pioneer in the development of quantum computing hardware and software. With their IBM Quantum platform, they are providing access to quantum computers via the cloud, allowing researchers around the world to test and develop quantum algorithms. Microsoft's approach to quantum computing is based on a unique platform called Quantum Azure. They are working on creating topological qubits, which are more stable than traditional qubits. Amazon's Bracket service offers a platform for exploring and experimenting with quantum computing, providing access to diverse quantum hardware. Intel is investing in developing quantum processors and collaborating with research institutions to advance quantum technologies. Startups and research institutions. Numerous startups and academic institutions worldwide are contributing to quantum research, exploring novel qubit designs, error correction methods, and practical applications. Recent advancements highlight the growing importance of quantum computing. JPMorgan Chase. The bank has demonstrated a real-world application of quantum computing by developing an algorithm for generating certified random numbers, which has significant implications for cryptography and cybersecurity. DARPA's Quantum Benchmarking Initiative. Companies like Rigetti Computing and IonQ have been selected to participate in this initiative, aiming to evaluate the feasibility of building a useful. Thank you for watching. If you enjoyed this video, please give it a thumbs up and consider subscribing to our channel for more insightful content on technology and AI. Don't forget to hit the notification bell so you never miss an update. Feel free to leave your thoughts and questions in the comments section below. We love hearing from you.